For the homework question in class, we were asked to determine the enthalpy of formation for this given formation reaction. And we were given these three reactions to work with. So if we start at looking at what we need on the left side and what we need on the right side, we can see that this reaction down at the bottom has SrCO3 on the left, but in our overall reaction we want it on our right. So we're probably going to need to flip this third reaction. We're going to want, if this is flipped, we're going to want something that can cancel that out. So we're probably also going to have to flip this reaction so that this ends up on the right, because this is going to end up on the left. So we're probably going to have to flip this reaction. Carbon is on the left here as we want it, and we're going to end up with this O2 on the left, and this 1/2 O2, once we flip that reaction, will also be on the left, so that should give us our 1.5 O2. The only other problem we have then here is that this bottom reaction is making two SrCO3s, but we only want one in our overreaction. So we're going to want to flip this and divide by 2. So let's write out our new root and see if it gets us to the right reaction. So first we want to flip this top reaction. So I'm going to take this and put it over here. And because I flipped it, I need to change the sign of delta H, so I'll put a minus sign there. The next reaction down we don't need to do anything with, and the bottom reaction we need to both flip and divide by 2. So if we're going to flip and divide by 2, that means I'm going to multiply this by -1/2 and flip and divide by 2. So first I'll divide by 2, so I'm just going to get rid of all the 2's here, and then I'm going to flip the reactants and the products. Okay, so let's see if we have the right overall reaction now. So we have 1/2 O2 and a full O2 on the left-hand side. So we have 1.5 O2 gas. On the right-hand side, we have an SRO here, but we also have an SRO there, so those are going to cancel. We have a CO2, but there's also a CO2 here, so those are going to cancel. And then on the left, we also have an SR solid, that doesn't cancel with anything, and a carbon solid, which is graphite, and that doesn't cancel with anything. And on the right side, we're just left with SrCO3 solid. So that's exactly the overall reaction we were looking for up here. To find the delta H of formation for this reaction, we simply need to add up all these enthalpies above, because we've already taken care of multiplying them and flipping them as needed. So we have -590 plus -393 plus -470 over 2. So I'll leave the units up for now, but we have -590 kilojoules per mole plus -395 kilojoules per mole plus 1/2 times -470 kilojoules per mole. That gives -1,220 kilojoules per mole for the formation of strontium carbonate.